Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be talking about organic chemistry and providing an introduction to organic chemistry, what you will need for your GCSE studies. So let's first talk about this word organic, which simply means containing carbon. So organic chemistry refers to molecules that contain carbon. And a brief refresher, we know that carbon on the periodic table, which has an atomic mass of 12 and a proton number of 6. That means that carbon has 2 electrons in its inner shell, first shell, and 4 electrons in its outer shell. That means carbon can form 4 bonds maximum. And a lot of carbon chemistry, organic chemistry, is based on the forming of this 4 bonds with carbon. So when it comes to organic chemistry, we know that we're talking about carbon chemistry and the way it forms bonds with other different molecules. One of the most simplest molecules you'll see is methane. And that's something you would encounter possibly when you're doing dot and cross diagrams. So this is an organic molecule. It's a molecule. We call it a molecule, a simple molecule, because it is a covalent substance. We say that because the bonds are made of sharing of electrons. And that's different than ionic substances, where electrons are lost or gained. So this is a covalent substance because the bonds, those little lines in between the carbon and the hydrogen, are made up of 2 electrons that are being shared. Hydrogen has 1 electron, carbon will have another electron, and they will end up sharing that 4 different times around the molecule. And that's something that we call dot and cross molecules, dot and cross drawings for drawing covalent bonding. So where does this name methane come from? And we're going to use that to talk about organic chemistry. So when a carbon molecule has 1 carbon, we use the prefix meth or meth. That means 1 carbon. So the number of carbons will be 1 in this case, 1 carbon. If it has 2, we use the word eth or eth. That's 2 carbons. And I can draw a molecule like that. And here's a molecule of ethane because it has 2 carbons. Notice the carbons are still bonded to 4 other atoms, in this case hydrogen. If it has 3 carbons, we call it propane, for example. And that has 3 carbons. And if it has 4 carbons, we call it bute or butane. And for GCSE, that's all you need to know. You need to know the naming up to 4. Of course, you can do 5, which is pent, and you could keep going all the way up to 10, okay, which is decane, and just continue and continue. But for GCSE, all you need to know is the first 4 prefixes, which is meth, eth, prop, and bute. We can draw an example of propane. See if we can move some of this stuff out of the way, and let's do it a bit smaller. So let's do methane again, which has one carbon and is bonded to 4 other atoms. So that's methane. Ethane, 2 carbons. Eth is the prefix for 2. Remember, carbon's bonded to 4 other things. Prop has 3. And we're putting the hydrogens in. Carbon is often bonded to hydrogen, but not only hydrogen, other things, but in this case, hydrogen. And bute, which is 4 carbons and has hydrogens bonded all around. Now, if you notice, I'm using the suffix ane, A-N-E. That's because all of these molecules belong to what we call a family of hydrocarbons, which we call the alkanes. Alkanes. And alkanes are carbons bonded to hydrogens with no double bonds. All single bonds. And there's a special name we give for this that we call saturated. We say the molecule is saturated. It's saturated with hydrogens. There are no double bonds. So this family of alkanes are hydrocarbons because they contain carbons and hydrogens. And we can name the alkanes by using, again, the prefix meth, eth, prop, bute, and the suffix ane for alkanes, for saturated hydrocarbons. Now, there is one final piece to this, what we call the general formula. The general formula for alkanes. And that is CnH2n plus 2. In other words, if you look at methane, methane has 1 carbon. So that's going to be C to the 1 carbon. And to find the number of H's or hydrogens, we do 2 times 1, which would be 2, plus 2, which would equal 4. And we can see that's correct. The general formula works. We can try that again with another molecule. In this case, we can look at ethane. Ethane has 2 carbons. So the general formula would be for the hydrogens would be 2 times 2, which equals 4, plus 2, which equals 6. And we can see that ethane does indeed have 6 hydrogens if we count them on the left side of the screen. So that's the general formula for alkanes, which is Cn, n meaning just a number, H2n plus 2. We can also look at another family that we call the alkenes. These are different than the alkanes that we discussed earlier. Sound similar, but they are different. These are unsaturated molecules, meaning they are going to have double bonds. So if we again use the prefixes, if we set methane, there will be no methene in this case because we need to have a double bond. That one doesn't exist. So we're going to cancel that out and we'll go to the next one, which is ethene. So eth again means two carbons. So ethene would have two carbons with a double bond in between. And now we're going to put the hydrogens around. Remember that carbon can only bond to 4 different atoms. So we can only use 2 hydrogens because the carbon is using 2 of its bonds in the middle here. And so it won't be saturated like the other alkane family. We can then do propene, which is 3 carbons with a double bond. And we put the rest as hydrogens. And finally, we can do butene, which is 4 carbons and a double bond. Making sure that each carbon is bonded to 4 other things. We use the same nomenclature, prop, eth, but, to indicate the numbers of carbons. So ethene has 2 carbons, propene has 3 carbons, and butene has 4 carbons. Now, just like with alkanes, which had a general formula, alkenes also have a general formula. The general formula for alkenes is CnH2n. So let's see if that works. Let's take, for example, ethene, which has 2 carbons. That means the hydrogen is going to be 2 times 2, which equals 4 hydrogens. And we can see that actually works in that case. So that is the second family of hydrocarbons. Hydrocarbons being molecules with carbons and hydrogens. There's another family as well, which we call the alkynes. And they are going to have 3 bonds in between. You do not need to know them in depth for GCSE, so we won't go into them there. But it's worth mentioning that we call these the alkynes. Now, 2 other families that you do need to be aware about in terms of organic chemistry are the alcohols and the carboxylic acids. An alcohol has what we call a functional group, which is a carbon attached to something else, of carbon to oxygen to hydrogen. So for example, we can use the same nomenclature from earlier. This has 1 carbon, and every carbon should be attached to 4 other things. And since it has 1 carbon, we say meth, so we call this methanol. It has the functional group of an OH at the end, making it an alcohol. Carboxylic acids are similar, that they have oxygen, but they have what's called a carbonyl group, which is a carbon to a double bond O. So we can make methanoic acid. This is methanoic acid because it has 1 carbon and it has the carboxylic acid functional group, which is the C double bond O to an OH. These are 2 other families that you should know, and they follow the same nomenclature. So for example, if I did this, 2 carbons to an OH, and I put the hydrogens in, well, we remember that 2 carbons, we say eth or eth, so we will call this ethanol. The same for carboxylic acids. If I had two carbons, we would call this ethanoic acid. Ethanoic acid. So to summarize, we've learned 4 functional groups. We've learned about the alkanes, which have a carbon single bond to another carbon. We call those the alkane hydrocarbons. We also learned about the alkenes with the ene at the end. They have double bonds. They're unsaturated. They have the double bond in between the carbons. We learned about the alcohol group, functional group, which have the C double bond to O to H. Alcohol functional group. And the carboxylic acids functional group, which have a carbonyl group, which is C double bond to O to an OH. We call the carboxylic acids. We can also discuss the difference between what's called the structural formula and the molecular formula. So the molecular formula is when you only write the atoms and their numbers. So for example, methane would be CH4. That would be methane because it has 1 carbon. Ethane would be C2H6. Those are molecular formulas. The structural formulas is when you draw out what they look like with the bonds. So methane as a structural formula would be CH4. Like that. That's a structural formula. And of course, I showed you some others earlier on. Remember again that these are called hydrocarbons because they are molecules composed of carbons and hydrogens. One of the key components of organic chemistry is learning about crude oil. Crude oil is a mixture of hydrocarbons. Some of those hydrocarbons have very short chains, some of them have very long chains, and you can learn more about the short and long chains and how useful products are made from these long and short chains through the use of fractional distillation in my fractional distillation video. But you should know at this point that hydrocarbons are compounds made up of carbons and hydrogens, such as methane, propane, butane, ethane, so on and so on. And that crude oil is a mixture of these hydrocarbon molecules. Molecules, again, because they're made of simple covalent structures bonding between 2 nonmetals, making them molecules.